Okay, example 10. If you look at this beam, this is example of a what? Cantilever beam. 10 upon by what? Uniform distributed load and a variable distributed load. I told you when you have something like this where they intersect, just trace this point out like this. You are going to see we are going to have something like this. When you trace it out, you will see this red line to continue. It shows that the uniform distributed load run from this point to this point. So let me call this point A, and this one is my point B. You get that? So we are going to convert it to a point load. So which is going to be what? Length times breadth. That is the total length. Length times breadth. The total length here is 10. So 10 times 2 is what? 20 kilonewton. So for this now, this, from here to here is what? 2 kilonewton, right? So, and from here to here is 6 kilonewton. So 6 minus 2 is what? 4. So it shows that from here to here is what? 4 kilonewton per what? Meter. So it shows that my area is what? Half base times height, which is half times the base is what? 6 times height, that is 4. So 2 here 1, 2 here 2, 2 times what? 12, 2 times 6, that is 12 kilonewton. You get that? So now, for you to draw the free body diagram, I told you if you have a fixed support, it's going to, because it allows no rotation of this beam, it will not allow rotation, it will not give, it prevents both horizontal and vertical what? Movement. So you are going to have something like this. You are also going to have something like this, and you are going to have moments. So now you are going to have MA, you are going to have RA, you are going to have HA. You get that? So now, and we say that our uniform distributed load is acting at what? The center of this. So, and when we convert that to point load, we have 20 kilonewton. And if it is like that, shows that from here to this end will be what? 5 meter, and from here to here will be what? 5 meter, because the total length is what? 6. So now don't forget we are going to have our right angle here. So now for us to get the distance this one will cover is going to be the L over what? L over 3, which is what? 6 over 3, which is what? 2. So it shows it will move 2 away from what? This part, so it shows that it's going to be somewhere here, so which is 12 kilonewton. So from here to here is what? 2 meter, and if it is 2, 6 minus 2 is what? 4 meter. You get that? So now the next thing is to calculate our horizontal force. Our horizontal force is going to be 0, and let's leave that. So now the next thing is to calculate our what? Summation of y forces. So positive equals to 0. It means we have only one upward force, which is RA. This one will be minus 12 minus 20 equals to 0. So RA will be equals to, if you add this one and this one, you are going to have what? 32. And when it crosses, it's going to be what? Positive 32 kilonewton. You get that? So now the next thing is to find our what? MA. So for us to find our MA, we take moment about what? About point A. So our moment about point A should be equals to what? 0. And when we are taking moment, we are going to have 2 force and this moment. So let me take this part. If you take this, it's going to be what? Clockwise moment. So 12 times 2 plus 20 times 5. Don't go and say 4 plus 2. No, this one is a what? Is a uniform distributed load, and it will cover what? The distance of what? 5. So it's there to confuse you. Please take note of that. So it's going to be 20 times 5. 20 times 5. Then don't forget that this one is moving what? Anti-clockwise. So it's going to be minus MA equals to what? 0. So now this times this is 24 plus 20 times 5. 20 times 5 is 100. Minus MA, so equals to, if MA cross here, it means MA will be equals to 124 what? Kilonewton meter. So that is the answer. Thank you. Then our next this thing, we are going to consider compound beam. Stay tuned as we come. Please don't forget to share all these beautiful solutions with your friends in various institutions that might be in need of it. Thanks.